Alright, last lesson we finished at exercise 2C, and let's have a look at the last part of this exercise. It is asking for 60% of all the possible height. Height is 16% of the possible height. Well, let's go back to this diagram we sketched. Okay, you know, like the larger the number, it will be more towards the right hand side. Okay, so it's negative infinity to positive infinity. So we want the top 16% on my right hand side. So can we have a look? This is 34%. So everything on that side will be just 16% because in total here is 50%. So 16% is a special number. It's actually to the right of the number after one standard deviation. So let's come back to this exercise C here. So top 16% is one standard deviation and onwards. So what is one standard deviation? Mu is 160 and the standard deviation is 8. So the distance of one standard deviation is 168 and to infinity. Okay, that is exactly 16%. Okay, so we have 160 here plus one standard deviation is 168, and everything else here will be 16% because here is 0.34. Well, the scale is not very correct. Should be this end. That's 168. Okay, that's 0.34 because it's within one standard deviation. That's 68%. So 1 is 34%, and then on the right hand side of that will be just 16%. So it's 168 to infinity. That's the all possible highs. Okay, higher 16%. Well, you can have middle 16%, you can have lower 16%, but the highest one will be from 168 towards the right. Okay, so that's this exercise, and let's have a look at exercise 3. Find the mean and standard deviation if a normal distribution has a symmetrical region. Okay, the important word here is symmetrical region. That tells us a lot. If you know two symmetrical points, you can find the middle, and the middle must be the mu. Okay, must be the mu. So it's always helpful to sketch a graph. It's alright, we don't know where exactly it is, but the shape is always a bell curve and x-axis is here. Okay, so that's the middle. I say that's mu, and you know that the symmetrical region is 52 to 116. So if we have 52 here, and then the symmetrical part is the same height, and then that's 116, that's 95%. Okay, that's 95%. So here is 95%, and if it's 95%, you know that's mu subtract 2 standard deviation, and that's mu plus 2 standard deviation because 95 is a magic number, and we want to find the middle first. So mu will equals to 116 plus 52 divided by 4. That's 168 divided by 4, that is a 42. Okay, 168. Okay, so here is 42. So from here to here and here to here, wait, the calculation is not that correct. 168, oh sorry, not divide by 4, it's divide by 2. Okay, half. I want to find in the middle, so is 84 here. That's why I find it's not that correct. So I have 84 here. So 84. Okay, so you use 84 to subtract 52, and that's a 32. And this side is a 32 as well. You can check it. 116. Okay, so standard deviation must be 32 divided by 2, which is a 16, because that's within 2 standard deviation. Okay, that's 2 standard deviation. 32 is mu subtract 2 standard deviation. So 2 standard deviation gives you 32, and one of that is a 16. So standard deviation is 16, and the mu is actually 84. Okay, that's example 3. Now let's have a look at example 4. given mu is 60, standard deviation is that. Find the probability in between that range. Okay, so that type of question will appear in exam 1. Okay, in exam 1 you don't have calculator. What you can do is put the x normal back to a standardized z normal, and then you see whether it's within -1, -2, -3, 0, 1, 2, 3, like those special numbers. Well, that's first type, and second type will be example 5. Let's have a look at example 4 first. Well, if there's no other information given, what I need to do is just put that on the z normal. So I'll put that on z normal. So how do I do that? I use the x, subtract the mu, and divide by the standard deviation. Use the x, subtract the mu, and divide by the standard deviation. And that gives me a probability. Okay, 24 minus 60, that's 36, and I think that's a -3. Okay, that's a 36, and -3, and less than. That gives me 12 divided by 12, which is 1. So that's within -3 to 1. Okay, if you have that, go back to this table. -3 is here. Okay, -3 is here to 1. Okay, 1 is here. Okay, 1 is here. So is 68% plus 2.35% plus 13.5%. Okay, so is -3 to 1. So 2.35, so 0.235 plus 0.135, 13.5, and plus 0.68. Okay, 68% is -1 to 1, and you have -3 to -1 as well. So 0.0235 plus 0.135, and that equals to 0.8385. So if you don't have your notebook, so you need to write that graph by yourself and then find the values. Okay, so that's 2.35% plus 13.5% plus 68%. That equals to 0.8385. Okay, so on the z normal, that must be special numbers. Must be special numbers. Okay, there's another type. Well, gives us that is a z normal. Well, it's a z normal. What's the good thing about z normal? It is the with mu 0 and standard deviation 1. Okay, with mu 0 and standard deviation 1. So I have this graph. Okay, I have this graph. I say less than a must be 0.72. So a must be a positive number, because if it's a negative, on the left hand side is less than 0.5. So a must be here. So here is 0.72. Okay, here is 0.72. If I can do this, because that's 0.5, that must be 0.22. Okay, here must be 0.22, and then that is 0. I'll put a little bit right here, 0.22, and then this part is 0.5. Subtract that, that's 0.28. Okay, 0.28. Less than a is 0.72, and then this to the right must be 0.28. Okay, that's the diagram I can sketch so far. And I say greater than a. Well, greater than a is 1 minus less than a. That's 0.28. Okay, less than negative a. Let's have a look. Negative a is a symmetrical point, so it must be this point here. So this point is equivalent to greater than a. That is, z is greater than a, and that equals to 0.28. Okay, greater, here's negative a. Well, greater than negative a is 1 minus probability z less than minus a. Okay, greater than minus a is here, so subtract this blue area here. That's 1 minus 0.28, that equals to 0.72. Or say that is equivalent to probability z less than a. Okay, greater than negative a is same as less than a. So that's 0.72 as well. Next one is probability z in between negative a to 0. So it's this rectangle here. That will be equivalent to 0 to a. Okay, it's the same rectangle on that side because it's symmetrical. So that's 0.22. So it's using 0.5 minus 0.72 minus 0.5. That's 0.22. Okay, next one is I'm looking for z in between that given z already greater than negative a. So negative a is here, 0 is here, a is here. In between those two values intersects with open circle, open circle, open circle, greater than a. So the intersection is still that part. Is okay, so we want intersects between those two numbers, and I have the top must be in between 0 to a, and the bottom is probability z greater than negative a. And we find that in between 0 to a is 0.22. Divide by greater than negative a is less than a, which is 0.72. And divide that by that, 2, 3, 6, 11 over 36. And you keep this number inexact because unless the question asks you to put into decimals, otherwise do not change it. Okay, let's have a look at example 6. If x is normally distributed with x less than a and x less than b is that. Let's sketch this graph. Okay, so the graph always helped. So it's a normal distribution, but without saying where is the mu. So I just draw a graph like that. Less than a, okay, here is the mu. Okay, always helpful if you sketch the mu out. Okay, that's the mu. Less than a is 0.27. And less than b is 0.81. So greater than b must be 0.19. Okay, so I'll say it's here, 0.19. Okay, on this side is 0.81. Okay, 0.81. Okay, so we have less than a 0.27. Then we have this part is 0.23 because it make a 0.5 together. And on that side is 0.19. 0.31 will be this part. That's the b. Okay, let's just add it. 0.5481. Okay, so that gives you less than b. Less than a is 0.27 and greater than b is 0.19, which is a correct graph. Then let's just have a look. Probability in between a and b is 0.23 plus 0.31. That gives us 0.54. Okay, 0.54 in between those two numbers. Less than a is here, less than b is that, greater than b is 0.19. So you add them up, that's a 0.46. Okay, check it, that's correct, which is the middle. So you want less than a and less than b. The intersection must be less than a, less than the smaller one. Okay, less than b, less than a, intersection is less than a. And you divide that probability less than b. And you have 0.27 divided by 0.18. That is 1 on 3, I think. Yes, 27 times 3 is 81. So 1 on 3 for that one. Greater than b, greater than a, intersection is greater than b, larger than the larger number. Okay. Greater than a larger number, larger than b is the intersection, over the probability larger than a. Okay, larger than b is 0.19 as we figure out here. and larger than A is 1 minus 0.27. Okay, larger than A is 1 minus 0.27. So what we have is 0.19 over 0.73. That's a 19 over 73. Okay, it's greater than A, which means that, so the answer is 19 over 73. Alright, so these are quite easy examples, like that's very likely to be a part 1 exam question. So everything on this page, okay, everything on this page is kind of exam 1 question. Let's have a look at exercise C. This is a very important exercise. It's just two cast instruction here. Okay, two cast instruction here. So let's have a look. If the number is not 0, 1, 2, 3, negative 1, negative 2, negative 3, how we can find the values on Z normal? There's no way we can do it. It's because in between 1, 2, 3 standard deviations are these special like proportions. Therefore, we can directly work them out. But if it's just like number 1.25, I don't know what is it. I need to put that into the cast and work out that. We are not expect you to remember all the values. Okay, it's impossible to remember all the values. Normally, in old days, people read through the table values. They give a table and list out like a lot of numbers there and say, oh, on the left of that number is what value, on the left of that number is which value. But we are not using old fashions. So let's just have a look at how to use calculator. So give you that the mu and standard, give you mean and standard deviation 0 and 1, and I want less than 1.25. So let's go to the calculator. Menu number 5, and I want normal CDF. Okay, we never use PDF, we use CDF in this course, and we also use number 3 later. So we want less than 1.25. It's negative infinity to 1.25. Okay, 1.25. And then mu is 0, standard deviation is 1. All good. And press 552, negative infinity 1.25, 0 to 1. Click OK, and that's the value. Okay, that's the value. So we have 3 decimal places, 0.894. Okay, 0.894. Okay, the next one is greater than negative 0.5. Okay, negative 0.5. Menu 552 is negative 0.5 is the lowest number, and I want infinity. Okay, infinity can find in pi as well. Pi. Okay, so 0 to 1 still because it's the standard normal, and click OK. So that's 0.691. 0.691, where it's greater than negative 0.5. And I want in between negative 2.3 and 1.4. Negative 2.3, and then I want 1.4. Still Z normal. Okay, still Z normal. Press OK. 0.909. Okay. 0.909. Alright, that's the first type. Well, if I say I want the number greater than, I want a value greater than 1.2. Okay, 1.2 to infinity. And it's not a Z normal anymore. Let's say it's just it's a mu with mu 10. Let's say mu with mu 10, 0.2. I just put mu 0.2 here, and with standard deviation 1.1. So I just press 1.1 here. So I click OK. That will give you the area as well. So I can just, if you know the mu, if you know the standard deviation, you can just directly work out any area you like. So another one, okay, exercise B is talking backwards. Okay, so what you know here is isn't that normal? But, and you have a number less than that number, the area give you 0.46. So, okay, what we have is a diagram like that. Okay, it's not very good diagram. Okay, like that. Can't sketch. Like that. So you know there's a number, exists a number A, and it's the only unique number. Okay, A maybe should be 0.5 is 0, so A should be here. So that's 0.46. Okay, you want to look for that number. You know the mu, you know the standard deviation, and you know the area. So what you need to find is the number give that area. So be careful. Okay, this is called the inverse normal. In our TIN SPI, okay, TIN SPI, in this CAS calculator, we can only find area on the left. Okay, smaller than number. If I know, like say, greater than A is 0.54, it's not working that well. You need to think about the left hand side. So then go menu 5, number 3 is the inverse normal. So there's only one place to ask you put area. So you understand, you can't put any area you like. You can't say, oh, I put area on the left or on the right. So the calculator won't know. So in this calculator, you must put the left hand side area, which is 0.46 for this one, 0.46, and that's mu is 0, standard deviation is 1. Press enter. That gives you negative 0.100. Okay, so this A is negative 0.100. Okay, so it must be the left hand side area. Let's look another example. Let's think about this one. Okay, give me the Z normal. Okay, to the right hand side of A is 0.28. Okay, on the right hand side of A is 0.28. So this is not working, okay, because it's on the right hand side area. So I need area on the left hand side. So instead, I need to go 0.72. So that's the left hand side area. That's the area I must use on my calculator. Well, they are the same thing. They're actually talking about the same thing. So probability that greater than A is not good. I need less than A. Okay, less or greater, doesn't matter. Less than A is 0.72. I need to use this equation to help me to work out the A value. So if you go menu 553, what you have is 0.72. Okay, it's less than that. So mu and standard deviation is still that. Well, if it's not, you just change your mu and standard deviation. You press OK, you have 0.583. Okay, A is 0.583. So that is the A value. Okay, that is the A value. So the important thing is use the area on the left. Okay, use the area on the left. Okay, the last one. Last one is interesting. First of all, you need to recognize those two are symmetrical points. If they are not symmetrical, well, it's a bit tricky. Sometimes you can't work on it. Well, if it's a symmetrical area, that's perfect, because in between negative A to A, you have 0.74. Let's divide that by 2. That's 0.37. Okay, 2 times 7, 14, 0.37, and then this area is 0.13. Okay, 0.13. So this area is 0.13 as well. So let's say you're looking for A. Okay, you're looking for A. So what you want to know is the probability Z is less than A. So Z less than A is 1 minus 0.13 minus the greater than A bit, and that is 0.87. Okay, 0.87. So you want to use this equation to help you to work on the value of A. So anytime you want to look for a number A, it must be Z less than A or X less than A. Okay, and you know that area. So that area is 0.87. Okay, 87. Okay, I have tried in the calculator by yourself. Okay, so we put that into the cast. 0.87, and still mu and standard deviation is the same. Plus OK is 1.126. Okay, so A is 1.126. Okay, A is 1.126. Okay, so that is the idea of this exercise. Okay, C is actually a very easy exercise. So it's just the use of calculator. So exercise B is important because we need to know that the area must be to the left of a point, not to the right, or not in the middle of a point. So we have C and exercise C, and example 8 is just using calculators. Okay, I already write the answers on it. Okay, I already write the answers on it. So let's just do one example. Okay, one thing needs to be careful with is this notation. That's n mu, and what you have for the second place is the standard deviation. It's not the standard deviation, it's the variance. Okay, so you can say that's n70 root 23 squared. Remember, it's n mu and standard deviation squared. So it's the variance. So 23 is not the standard deviation. Instead, it is the variance. Okay, so if you're looking for, we need standard deviation all the time. So if you know standard deviation, you want root 23. Okay, it's root 23. Okay, all the same for that, and for that. Okay, everything is the same. So, okay, I'll just do one example in A and show you one calculator used in A and one for E. Okay, and you can do the rest and compare the answer here. Okay, that is the answer for every single question. I leave 3 decimal places as well. So let's have a look at A. A says x less than 135. You want that probability. And x is normally distributed with mu 154 and standard deviation 19. It's very straightforward. Okay, menu 552. When you want to find area, you use normal CDF. Okay, so you want less than 135 is negative infinity to 135 with mu 154 and standard deviation 19. Okay, just type all the informations in. You're looking for probability, you use normal CDF. Then the probability is 0.159. Okay, 3 decimals, 0.159. Okay, same as B, just be careful, the standard deviation you put must be square root 23. Okay, square root 23. Let's have a look at E. Okay, E is 98th percentile. Okay, if you remember percentile, okay, is when x less than a number that will give you 0.98, like 98%, or quartiles, like same as percentile, is just 1 in decimal 0.98 quartile or 98th percentile. So you know that what you can write for 98th percentile is probability at x less than a equals 0.98. A is the percentile. So you know that already is minus 553. The area to the left of A is 0.98. The mu is 50.8. And the standard deviation is square root 10.4. Okay, square root 10.4. Because that's what gives you there is standard deviation. Okay, 10.4. What gives you there is variance, and you want standard deviation. And you have 57.423. Okay, 57.423. So A will be that. A is also the 98th percentile. It is also called 98th percentile. Okay, it's the end of this lesson. So we will continue with the tomorrow. And this is the basic. Okay, this exercise is the basic, which is very important.